Okay, so good morning. Today I'm going to explain a little overview of this chapter, Numerical Methods, chapter 12, okay, in your SEM2 syllabus. Okay, this chapter is divided into two sections. Okay, the first part is on solving equation and the second part is on numerical integration. Now, under solving equations, okay, first we will do the part on solving equations. Okay, you have two methods to learn: method of iteration and Newton method. Okay. Method of iteration, okay, is involved in solving equation. So the equation that we want to solve, okay, we put it into fx equals to 0. Okay, the formula that you're going to use, okay, this is the formula for method of iteration. X sub n plus 1 equals to f of xn. Okay, you're going to take the equation of fx equals to 0, rearrange it so that you get x, only x on your left hand side and the rest of the stuff on the right hand side. Okay, take the equation that you want to solve. Okay, put x on one side, on the left hand side, and the rest on the right hand side. Okay, now once you have that, approximate the value of x naught. Okay, you get your value of x naught, roughly the value that's approximately close enough, approximate to your real root that you want to find. Okay, so your first approximation will be your x naught substituted into your capital F here, capital Fx here. Alright, so you need to have your x naught to approximate, to get the first approximation. Okay, by the same process, to get the second approximation, you're gonna put in your first approximation value, the value that you just got, put it back, okay, substitute it back into your fx. Okay, now we will do this many times until you get the approximation that is close enough, accurate enough to be your answer. Okay, there are two parts here. Method of iteration will be divided again by two parts. You're gonna solve it using graphical process and then using numerical process, using the same formula actually. Yeah. Okay, so later in the next video I will do the graphical process. Okay, I'll show you how to do the graphical process in the next video. Right? Okay, let's move on. Okay, so this is the overview of the chapter. Move on to the second method, okay, of solving equation. Okay, the equation that you want to solve, put it into fx equals to 0 right here. Okay, now the formula you're going to use, okay, under Newton-Raphson method is this one right here. X sub n plus 1 is xn minus fx, okay, the same fx that you want to solve, except that you substitute x with xn, okay, divided by the differentiation of your f, differentiation of the equation that you want to solve, okay, substitute in your value of xn. Okay, so if you want to get your first approximation, okay, same thing like the previous method, you're gonna have to guess your x naught, guess your initial guess. X naught is your initial guess. Get your initial guess first to get your first guess. Okay, your first approximation will be your initial guess minus f with x naught substituted in, divided by f prime with x naught substituted in. So notice here, using Newton-Raphson method, you're going to need to do some differentiation. Okay, you're going to have to differentiate your equation that you want to solve. Yeah, so you have your differentiation here. Okay. So similarly, if you want x2, the second approximation is gotten by getting your first approximation minus function with x1 in it divided by f prime with x sub 1 in it. Okay, hope that's clear. Now the last part of this chapter deals with numerical integration. Okay, the method that you're going to use, or the method that is taught in this chapter, is trapezium rule. The formula that you want to use, okay, is here given. Okay, any function that you want to integrate, fx, you want to integrate between a to b, lower limit, upper limit, okay, fx with respect to x, okay, that means you're looking for area here, area under the curve of fx from a to b. Okay. That can be approximated by half of h. Okay, h is a constant width. Yeah, later we'll get into that. Half of width times y naught. Okay, first y, plus the last y, yn. Okay, plus 2 of the total of y in between. Okay, from y1, y2 up to y sub n plus 1. Alright, that's the formula. Now h, what is h? H is the width. Yeah, so h is upper limit b minus lower limit a, so the difference between upper and lower, divided by the number of strips. Okay, what are strips? Okay. If you look at this function, if you look at this graph, okay, the sketch here, this is a strip. Okay, one strip. The one I shaded here is one strip. Right, so this formula here is to find the area of the area under this curve. Okay, so this is y equals to fx. Here, this is fx. Right, equals to fx. So you want to get the area between a and b. Divide it into as many strips as you want, or as specified in the question. Okay, strips, that means you will have values of y that goes from y naught, okay, the first value of y here, y naught, second value y1, so from y naught to y1 you have one strip, y1 to y2 another strip here, okay, and so on, y3, y4, y5 up until yn, right? So yn is the value of function when x is b. Y naught is the value of the function when x is a. Okay, so that's the number of strips. This is h. Okay, the width, constant width, yeah, which is b minus a divided by the number of strips you have. Right? So that's the overview of the whole chapter 12.